Solving proportions using relationships and algebra. We've got 3 learning goals for this lesson. To understand that a proportion is a mathematical statement showing that 2 ratios are equal, applying algebraic techniques such as isolating the variable or using cross multiplication to find the missing value in a proportion, and using proportional reasoning to solve practical word problems. What is a proportion? A proportion is a statement of equality between 2 ratios. As an example, we can say 4 is to 5 as 12 is to 15. We could also write that in its fractional form of 4 over 5 is equal to 12 over 15. And it's important to recognize that we read it as 4 is to 5 as 12 is to 15. The colon symbol means is to, and the equal sign means as. Ratios are related by multiplying or dividing within the proportions, but never, and we mean never, adding or subtracting. And you'll see how that works as we work through some examples. Let's try a couple examples. We've got 3 is to 4 as 6 is to x. We want to get the x all by itself. Ultimately, we want to know what x is equal to. So we're going to cross multiply, and we end up with 3x is equal to 4 times 6. Now you should remember from previous math that to get rid of the 3, we want just the x alone. We're trying to end up with something that just says x equals at the end. So to get the x alone, we have to divide both sides by 3. Divide that side by 3 and divide that side by 3. That'll cause those 3's to cancel out, leaving us just with x is equal to 4 times 6 divided by 3, which is 24, divided by 3, which leaves us with x is equal to 8. Let's look at the next one. We've got x is to 7 as 30 is to 21. So we've got x is to 7 as 30 is to 21. In this case now, because the x is on the top, I don't need to do the full cross multiplication like I normally would. I can do a little bit of a shortcut here. I'm going to multiply both sides by 7, which will cause that to cancel out, and then I multiply the other side by 7. So I end up with x is equal to 7 times 30 over 21. So remember, whatever you're doing to one side of an equation, you have to do to the other side of the equation. So because we wanted to get rid of that 7, we multiplied by 7. Since we multiplied this side by 7, we have to multiply the right side by 7. That leaves us with 210 divided by 21. I can see that the top here is 10 times bigger than the bottom. So I end up with 210 divided by 21 is just equal to 10. So in that case, x is equal to 10. Try this one, pause the video, and then come back and see the solution. Similar to the last problem, if we want to get the x all by itself, we're going to have to multiply both sides by 40. In doing that, we end up with 40 times 10 over 20, which is equal to x over 40 times 40. Those 40's will cancel each other out, leaving us just with x on that side. And over here, we end up with 4 times 10, which is 400, divided by 20. If you're not sure what that is, you can see you can scratch off those zeros, and now you've got 40 divided by 2, which is a little easier to do. You've got, therefore, 20 is equal to x, or x is equal to 20. Here are some more for you to try. Try them yourself, pause the video, and then come back to see the answers. Here are the answers for those questions. Check your solutions. Now let's try this one. It's a little bit different. Try it yourself and then watch the solution. So we've got y is to 3 as 4 is to 10. Following what we've done previously, we're going to multiply both sides by 3. So we've got 3 times y over 3. That's going to cause those 3's to cancel each other out. And then we've got 3 times 4 over 10. So we've got y is equal to 12 divided by 10. We know we can reduce that 12 divided by 10 to 6 over 5, which is also equal to 1 1/5, or if you're working in decimals, is also equal to 1.2. We don't usually put decimals or mixed numbers or improper fractions into ratios. However, it makes sense in this case. Imagine that you had been given a recipe that said the ratio of eggs to flour is 4 to 10, and then it told you that you've only got 3 cups of flour. You want to know how many eggs are you going to use with that 3 cups of flour. So in this case, it would make sense that you would have 1 1/5 cups to work with your 3 cups of flour. Looking at this more visually, you can see that if we do the cross multiplication, we end up with 2 smiley faces are equal to 5 stars. And similarly on here, if we cross multiply, we end up with 3 smiley faces are equal to 4 stars. If you wanted to go further, you could say, therefore, a smiley face is equal to 5 stars divided by 2. So you're dividing both sides by 2 to get the smiley face all by itself. And similarly on the other side, if you've got the smiley face, you're dividing that side by 3, so then you've got 4/3 times the star. Looking at it using letters more algebraically, we do the cross multiplication, and then we end up with A times D is equal to B times C. We can also rearrange that further. If we divide this side by A, we have to divide the other side by A, but what that gives us then is the A's would cancel each other out, and we'd end up with D is equal to B times C divided by A. Or we could have gone the other way, and we could have divided by D, divide both sides by D, and we end up with A is equal to B times C over D. So you can rearrange to find any one of the missing variables quite easily. Let's try an example then. We've got 2/3 is equal to 15x. We end up with, therefore, 2x is equal to 3 times 15. Dividing both sides by 2, we end up with x is equal to 45 divided by 2, which is equal to 22.5. There's also another little trick you can keep in mind. If 2 is to 3 as 15 is to x, you can flip both of those upside down, and the ratio is still the same. So we can say 3 is to 2 as x is to 15. Then all you have to do is multiply just this way. You don't have to do the full cross multiplication. So you can say 15 times 3 over 2 equals x. So you're back to exactly the same solution. Now let's look at a word problem. We're told that a 450-kilometer trip required 32 liters of gas. We're asked how far could we travel if we had 50 liters of gas. This is a proportions problem. So we can go 450 kilometers on 32 liters of gas. And we know we've got 50 liters of gas, and they're asking us how far can we go. The key to this problem is the setup. After this, it's just cross multiplication. So you've got 50 times 450 divided by 32 is equal to x. And you end up with x is equal to 703.12 kilometers. And since it's a word problem, we should always finish off with a sentence statement that says we could travel 703 kilometers on 50 liters of gas. Here's another one. It tells us that 12 out of 15 students prefer chocolate ice cream over vanilla, and then asks how many students prefer chocolate if you have a group of 200 students. We start with the first ratio of 12 out of 15. We know we're dealing with a group of 200 students in total, and we just want to know how many of them prefer chocolate. So the key to this is in the setup of the proportion. To get rid of the 200 over here, we're going to multiply both sides by 200. So we'll end up with 200 times 12 divided by 15 is equal to x. And if we multiply that out, we end up with x is equal to 160. Writing our concluding statement, therefore 160 students would prefer chocolate. Now it's your turn. Try the homework.